Hello everyone. Our today's topic is the rates of reaction or reaction kinetics, how the reaction moves, how the reaction takes place. The rate of reaction is defined as change in concentration of reactants or products per unit time. This is called as the rate of reaction. Now, graphically, rate can be represented just like these two graphs. This graph is for the products because at the beginning the concentration of product is 0, but with the passage of time it increases, but the rate of increasing slowly decreases, and finally when this curve becomes horizontal to the time axis, it means that reaction is stopped, finished. And now this graph is meant for the reactants because the concentration of the reactant in start is very high, and when reaction starts the concentration of reactants decreases, but the rate of decrease of the concentration of reactant decreases with respect to time, and automatically whenever both of these curves become horizontal to time axis, reaction is stopped. We know that if as this curve move towards the y-axis, this indicates the reaction is becoming faster and faster and faster, so on, and vice versa. Now, along with these curves, we can also mention the reaction pathway. In case of exothermic and endothermic, we have already learned in previous classes that this curve meant for exothermic and this is for endothermic. This is for exo and this is for endo. Now, this energy curve or this energy barrier in front of reactant, this is called as the energy of activation. What is the energy of activation? Actually, the energy of activation is the bond energy of the reactant molecule. Whenever the energy of the system increases, then the bond energy of the reactant molecules automatically older bond will be broken up and the reaction will take place. This is the energy barrier, and this energy barrier is larger in case of endothermic reactions. But if we use catalyst, what is catalyst? Either it is enzyme or either it is a transition metal or its compounds. The function of all the catalyst is to decrease the energy of activation. Now whenever we will add catalyst, it will decrease the energy of activation. So energy requirement for the reactants to convert into product will be decreases automatically. And decrease in energy of activation will increase the rate of reaction. Now, rate of reaction can also be explained using collision theory. For example, one molecule of one substance collide with one molecule of the other substance. Definitely, if the energy produced as a result of collision is larger than the bond energy of the both molecules, automatically the older bonds of reactant substances will be broken up, and then new bonds immediately will form, and we will say that the reaction is spontaneous and the reactants are changing into the product. But if both of these molecules collide but the energy produced is lesser than the bond energy of the reactant molecule, it means that reaction will not take place and their previous bond will retain as such. This is the collision theory. What will be the effect of the concentration and temperature over this? For example, if we increase large number of molecules, means if we increase the concentration, it means that we are increasing molecule. What will happen? The number of collisions per unit time will be increased too much, and whenever they will collide, then there are chances of formation of activated complex, which is a higher energy state, and more chances will be there, and then from the activated complex, the more chances will be the production of the products. That's why the collision theory is responsible for explaining the rate of reaction. As we will increase the molecule, more collision, more chances of activated complex formation. And then second is the effect of temperature. If we increase the temperature, it means that kinetic energy of both the reacting molecules or reactants will be increased too much. As a result of which, if their kinetic energy will increase, they will collide tremendously, producing more energy than the bond energy automatically by increasing the temperature. Then older bonds will be broken easily, energy of activation will be overcome easily, and the rate of reaction will increase as a consequence. Now, this can be explained using this graph. This is energy profile or Boltzmann distribution curve. For example, this is the axis. On x-axis, molecular energy is there, and on y-axis, the number of molecules are there. Now, area under this curve represents total number of molecules from there to this area. For example, if this curve represents the total number of molecules at a lower temperature, then at this temperature, only this much portion of the molecule is able to form activated complex and then to change into the products. It means that majority of the molecules have lower energy. They cannot produce too much energy equal to the energy of activation. That's why those molecules will remain as a reactant as such. But if we increase the temperature, then what will happen? Whenever we will increase the temperature, now the curve will go from this side or move from this side in this manner. It means that the more molecules from the lower energy will shift to the area where the molecular energy is higher. Whenever the molecular energy will increase, automatically the chances of activated complex formation will also increase. Say this curve we have built up at 25 degrees centigrade, and this curve will be definitely at 50 degrees centigrade. As we will increase more temperature, then more molecules will move in this manner. It means that more and more number of molecules, more and more fractions of the molecules are moving in that area or gaining more energy, which is sufficient to overcome the energy of activation, as a result of which the energy rate of reaction will automatically increase. Now, if we use side by side a catalyst, then what will happen? Due to the presence of catalyst, if energy of activation is decreased, automatically this much energy will come at this point. For example, this is a catalyzed energy of activation. It means that whenever the energy of activation decreases, the fraction of the molecules able to build up transition state activated complex, that will increase, so the chances of the formation of the products from reactants will also increase. Now, in this manner, we can increase the rate of reaction using catalyst or by increasing the temperature, and that can be represented using the Boltzmann distribution curve. I hope I have explained all of the concept regarding rate of reaction. Please like, comment, share and subscribe the YouTube channel.